Okay, we're looking at the second year Stats and Mechanics textbook, and we're on chapter 6, which is projectiles, looking at exercise 6D, which is on projectile motion formulae. So we're doing 7b. We've split this up over 2 videos just because it's quite long. Okay, so 7b, we're given the angle. So it almost makes it just a standard question, but we're not given the initial velocity. So let's just, first of all, before we do any calculations, think about what's actually going on here. So this volleyball is being hit, and it's going up for a bit, and gravity is pulling it back down, and they're saying it just gets over the net, and they're asking us for its speed at that point. So that's the volleyball net. It just makes it over. So we're going to sort of say it's literally at a height of 2.4 meters. So the speed, I need the vertical velocity, the horizontal velocity, which is going to be constant, and the vertical velocity. And I can see from their sketch that the vertical velocity is downwards at that point. Okay, and then the speed is going to be the magnitude of those two vectors there. Okay, and then that's, so at that point it's traveling down like that. So basically, whenever they ask for the speed, you need to find the vertical and horizontal velocities. Right, so they've given me alpha, but they haven't given me u. It's unlikely that B is going to be unrelated to A. It might just be a completely separate part of the question. But if I, this whole question is quite challenging. So if I think though, well, what would happen if I substituted that 30 degrees into this result from A? And I would just be left with u squared. Yep, so if I know alpha, I know tan alpha. If I know alpha, I know cos alpha. I know g is 9.8. So that will allow me to get a value for u, the initial velocity. So let's do that. So 0.9 is 9 tan 30 minus 81, g is 9.8 over 2u squared cos 30 all squared. So I'll just write it like that, so just so you're careful putting it into your calculators. So I think I will sub those values in now and then rearrange. So I'm going to get 0.9 is 3 root 3. Let's just move that up a bit so you can definitely see it. Minus 81 times 9.8, so minus 793.8 over, so I'm going to do the cos 30 squared and then times by 2, and write that as a decimal, so over 1.5 u squared. Okay, so then I just need to think about sort of how I want to solve that. I'm just going to get rid of this diagram for now. So I would do that. I think because I don't really like the negative, I think I would add that fraction over to the left-hand side. I would do the 3 root 3 minus 0.9. So take the 0.9 over to the right-hand side. My answer is not going to be in the exact form anyway, so I'll start going to decimals. Let's just go to 5 significant figures just to be on the safe side. So then I would just multiply up by the u squared. I'll write it out stage by stage. There's no reason to multiply by the 1.5. In fact, let's just save a little bit of time. So, and then I'll divide by the 4.2962 at the same time. Okay, you may do those steps in a slightly different order, but as long as we get to the same point, we're fine. And in fact, I haven't cleared the 4.2962 from my calculator, so I don't need to worry about losing accuracy. So I'm going to times that by 1.5, then I'm going to do 793.8 divided by that answer, and that gives me u squared is 123.18. So u is 11.0 0.099. So if that was my final answer, it'd be 11.1, but I'm going to use that in a further calculation. So I'll leave that to a higher level of accuracy. Okay, so that's the initial speed of the ball. So now it's actually just become a question where I'm given all the information I need. So I'm given that angle is 30 degrees. I know from my calculation that's 11.099. Okay, and we'd already said previously, I'll sketch it out again, but basically I'm trying to find the speed when it goes over the net. So say that's the net there. So I can see it's going down and to the right. And if I think about it, so the horizontal velocity is not going to change. So the horizontal velocity is just going to be, well, so previously we'd already said it was going to be u cos alpha. We had to do that for part A. So if you can't quite remember that, it's basically that. So it's the side that's adjacent to the 30-degree angle. And then, but now I can actually give that some values. And just get, so that's going to be the horizontal velocity, and that's not going to change. So that will be the initial and the final horizontal velocity. Vertical velocity will change because of acceleration due to gravity. Why don't I just spread this up a little bit, actually, and you can keep that on there. Right, so vertically, and again, you've already had to consider all this for part A. So the initial vertical velocity, I'm going to take up as positive. So the initial vertical velocity, so that component of the velocity, so that's opposite the 30-degree angle. So that's capital U sine 30, which we can now say is 11.099. No, so half substituted and half didn't. So I meant to put U sine alpha, which is 11.099 sine 30. I'm taking up as positive, so acceleration is down due to gravity, so that's going to be minus g. I know when it goes over the net, it's travelled 0.9 meters in the vertical direction, because it started at 1.5. The volleyball, the girl hit it upwards, and it passed over the net that's at a height of 2.4. So its vertical displacement at that point is 0.9. So, and that's 0.9 above where it started, so that's going to be positive 0.9. Again, we already had to use that to answer part A. And I want its vertical velocity. So I am going to use v squared equals u squared plus 2as. So v squared is, let's just put that into the calculator now. So in fact, I haven't cleared the u from my calculator, so I've still got that exact value. So I did just clear it then, so I have no longer got it. Right, never mind. Okay, so I get that to be 5.495. Okay, so v squared is 5.5495 squared plus 2 times minus g, so minus 9.8 times s, which is 0.9. So let's do that with the calculator. So that's squared minus 2 times 9.8 times 9.8. Let's say 9.8 times 0.9. Right, so there we go. Okay. So that's giving me v squared is 13.16. And if I square root that, I get v squared, or sorry, I get v is 3.627. Let's go for. Okay. I'll put the units. That's not my final answer, so I don't think it'd be a problem if I didn't put the units there. Okay. No, so actually, that's not totally correct, is it? And now I think about it, because when I square rooted, I should have considered positive or negative, and I'd already said at this point where I'm looking, it's a different colour. So here, it's going downwards, so it should be a negative velocity. Now that actually wouldn't affect my final answer, but depending on how harsh they were being with marking my method, that could cost me a mark. So the reason there is two velocities is there is actually, so if this is the path of the volleyball, there is going to be, so I'm going to write most of this, let's rub some of this out, right, let's get rid of that. There is going to be 2 points where the velocity, where the displacement is 0.9. Yeah, there's going to be a point on the way up, so that's when the vertical velocity is positive, and then a point on the way back down, and that's the one we're after. So actually, that velocity, because velocity is a vector, half blue, half black, so that is a negative velocity. We're really close to finishing this question, and my final stage is basically going to be to use Pythagoras, where I'm going to square that anyway, so it's not going to matter, but just to be technically correct. Right, so we always had the horizontal velocity because that wasn't changing. Although, oh yeah, that's where I put that. Oh. Okay, so that's the horizontal velocity throughout. So in fact, let's do that into the calculation now. So 11.099 times cos 30. So I get that as 9. I get that as 9.612. So the horizontal velocity was a constant 9.612. The vertical velocity we've just worked out is down 3.627. So what they actually wanted, the speed, which is going to be the magnitude of the velocity. So that is just going to be Pythagoras. So speed squared is 9.612 squared plus minus 3.627 squared. So squared plus 3.6. So this is why the negative actually wouldn't affect my final answer. So I'm getting 105.55, which therefore if I square root, oh, sorry, I can't see that. If I square root that answer, gives me a speed of 10.3. Okay, so let's keep our fingers crossed and check that answer. Fantastic.